Yeah, so excited to be here today to be speaking at the Confer Conf 2021. My name is Hans Christian. I'm from Bergen. I have 3 pods, small to large size. We're running around here at home. School is closed, so apologize if one of them might be storming in. I am the site reliability engineering and DevOps practice lead for a small company called Tieto. Previously, I worked at the Norwegian Tracking Association, or DNT. I made ut.no, if you're familiar with that. If not, go and check it out and start planning your summer vacation. I'm a member of the Node.js Foundation, and I'm all over sort of an open source evangelist. So this talk will be very near and dear to my heart. Just briefly, sort of overview, sort of this talk here is based on our experiences, me and my team's experiences with sort of platform engineering at Tieto, working with some large telecom providers, financial institutions, banking, insurances, government, public government, retail, and maritime. So huge sector across the boards, and we found that these practices fit very nicely into the various types of organizations here. And sort of just fits sort of a little bit oddly put into the presentation, but again, sort of we all know that sort of this culture eats strategy for breakfast, sort of implementing a sort of platform engineering, platform developer, platform strategy, platform engineering, or DevOps, or what have you, isn't just something that you just decide in some board meeting and write in some Word document or a Confluence page or a PowerPoint, and then, oh, now we are doing this. It starts with the people who will actually be affected, and sort of involving them is so critical to the success of everything that I'm going to talk about today. And what I'm going to talk about is this practice of platform engineering and how we sort of create developer-friendly, application-friendly platforms for our various engineering teams. And who are those teams? And sort of these are just engineers, as we sort of like to call them, sort of being inclusive. You can have all types of engineers here, developers, of course, front-end, back-end, database administrators, system administrators, operators, digital experience, more on the customer side as well. And sort of let's just stick with engineers to be inclusives. And they come in all types of forms and shapes and colors. As you can see here, these are just some examples. And it's so important to remember that these are humans too. These are first and foremost humans. They are not resources to be allocated and just some number on some Excel sheet. And sort of they require a lot of empathy. Humans in general require sort of that you connect with them, you understand them, and you actually have to talk with them and sort of understand their needs and acknowledge their needs. And for all of the organizations that I've been involved with, they are probably the most expensive of everything that the company is doing. And they are so scarce. Having good people with the right competency is so hard to find, at least in the Norwegian market. It's so much competition about these people with their unique skills. So be able to actually have them continue to be employees of your company is so important, and we're seeing companies more and more acknowledging this. It's not as simple as sort of the money in and the money going out. You actually need to think about this developer happiness or engineering happiness. And they are lazy in a good way. Don't misunderstand this. They are sort of finding the path of least resistance. So if you put up too many sort of too many gates and chokeholds, they will definitely find a way around that. I've seen sort of where if you glue all of the sort of ports, they will manage to find some other way to get that file to wherever it needs to be, and then sort of probably doing it in a very in a rather suboptimal and not the most efficient, maybe not, definitely not the most secure way. So sort of flipping that around, sort of giving them options, sort of giving them secure and best practices options to work with, instead of having them to figure out all of this. If you just say that, oh, you can't do this, you can't do that, you can't do that, this other thing. And they want choices. As humans, we tend to do that, and we are all adults. We should be responsible enough to be able to take to have some say in what we do. But there is a difference between sort of having no choice and having a million choices, and sort of striking that balance, finding a couple of different options. That's typically what we humans are better to be working with, not having a totally white piece of paper, but having some shapes and forms that you can choose of. And then most of us, we like to focus on what we are good at. We want to be sort of challenged, and we need to be challenged, but we want to primarily be focusing on what we are actually good at. What is my role? What is my core competency here? And then sort of playing to that advantage. And this sort of brings why most organizations are adopting DevOps. And just to give so we are on the same page, what is DevOps? DevOps is first and foremost a culture. It's the sort of process of reducing organizational silos. So reducing the barriers between, as the name suggests, developer and operations. This includes having the testers on board. This includes having the release engineers on boards. Of course, UX front-end developers are working together with the back-end developers and and the architects, and also security. I really tend to not use the word DevSecOps, as sort of it's implied by the meaning that, of course, security is part of the entire life cycle, and the security engineers and security professionals have to be included here when we are talking about reducing these silos. And is this notion that no matter of how much time, how much rigor in our process, there will still be failures. Of course, the code and things that you do is perfect. It's never failing. But then there's everything else outside of your control, outside that you're in these very complex and sort of distributed and sort of composed systems that we are working on, and sort of accepting that there will be failures. Let's find other ways to sort of more handle that when they do that, and sort of mitigate the impact of those. And to actually reduce the failure rate, we have this implementing gradually change, that we are not doing these very big bang releases anymore. We are splitting up our large applications so we can roll them out independently, and then we are going to roll out changes gradually. And of course, leveraging tooling and automation. But as you can see, this is coming in as on the fourth place. This is first and foremost culture and process and the way of working, and then we are finding the right tooling to support the way that we want to work, and of course measure everything, that we get this constant feedback when we are doing anything. And DevOps didn't sort of wasn't created in a vacuum. It was really sort of hand in hand with the introduction of public cloud and cloud computing, and it's sort of been one of the fundamental building blocks of this, what we call cloud native. And it sort of relies on the DevOps way of working, of course, leveraging continuous delivery, often splitting up the huge application into more microservices and sort of more software as a service purchasing and getting rid of the maintenance and sort of the ownership, and focusing on the core bits and pieces. And then often, even if you're not using containers directly, there might be some containers under the hood there. And then I briefly just want to touch on this it's an important topic. This DevOps engineer, and it's rainbows and unicorns. There is no such thing as a DevOps engineer, and I'll just briefly explain to you why. Because DevOps, that's this culture and process. This is the way of working. Then we have cloud native, which is our architecture principle. How are we going to design and implement our systems? And when it comes to actually describing a role in a team we have this site reliability engineering. And this is from the site reliability engineering workbook. As you can see in the link, please check out the link if you're not already familiar with SRE, the SRE principles. Google have written three books on the topic, along with other companies. This is not something that they are only applicable to the companies of Google, but small and large, this is highly recommended. So it's the class of SRE implements the abstract interface of DevOps. So it's very much in line with the DevOps way of working, but it's a little bit more opinionated on how this person or persons rather are going to work, because there is some ambiguity when it comes to DevOps. It's many companies have their own definition. What is DevOps? What does it mean to them? But it has this very, very strong focus, as you can see here, checking all the boxes. It's very much in line with DevOps. It's a shared ownership, so you don't have developers develop and the SREs operate. There's this very explicitly, we are sharing the ownership of the application. With accepting failures as normal, that's where the SRE principles are most opinionated, is that is too vague. What is normal? What is a failure? And what level of reliability are we actually targeting here? So much agreeing on what is the stability level, and using service level objectives and these blameless post-mortem when something goes wrong, to be able to learn from these types of incidents. And then the implement gradual change is this reducing cost of failure, and it has a very explicit that you have this amount of failures, and you need to plan, be a little bit smart when you plan in how are you going to use that failure budget, this error budget. And then very strict on automating this year's job away. If you keep accumulating manual work, or toil as they call it in SREs, you will not be able to scale. We will need to add on more people all the time, and it will you will fail in that regard. We need to make sure that we are focusing on these newer tasks and what's giving continuous or permanent value to the organization. And then of course measuring what are the overhead, what are the amount of work that we are doing that this doesn't give us lasting values, and what is the reliability that we are actually achieving. And a popular quote by Ben Traynor, VP of Engineering at Google, SRE, what happens when you ask a software engineer to design and operate operations functions. So having the software development in mind from the very start. And most organizations are on this DevOps evolution model. This is put forward by the State of DevOps reports that comes out annually. And you have this very normalized, very standardized technologies. You expand on your reusable services. And most organizations are well on their way, typically on stage 3 here, and beginning to seeing that the development team using agile practices are able to outperform the operations, and starting and then automating more and more of their infrastructure. And then at the very end here, you have this self-service, providing self-service capabilities to the rest of the organization, not having to order something through a service desk or a ticketing system or email or asking a person or a team, but able to actually do this job on your own as an autonomous team. And there's been some or actually a lot of studies regarding sort of what is are there any common themes to sort of the high performance versus the low performance when it comes to sort of transforming to a DevOps way of working? And what we can clearly see is this sort of having training centers, center of excellence, and proof of concept installed. That's typically sort of characterizing the low performance training centers as sort of like, oh, let's pull people out of their daily job, let's train them, and then put them back into what they previously did. So center of excellence is sort of a chokehold, sort of, oh, we are going to put all of the expertise in the organization in this one unit here. Typically creates a bottleneck. And proof of concept install is typically sort of you're creating a proof of concept, but you don't have any sort of mandate or any sort of idea how to use that forward. But what we see sort of on the high performance scale is sort of communities of practice, sort of not pulling out people, but actually sort of, okay, let's a communication, let them flow between the teams and sort of sharing good practices and we see sort of bottoms up grassroots movements that sort of again sort of establishes the culture that we need and sort of gives ownership to everyone in the organization. And then you have this sort of proof of concept as template, where you create a proof of concept and you sort of make a reusable template out of it. And then other teams can then use it without sort of having to go through the entire proof of concept, but sort of rather just spin that up as a sort of a bootstrapping or enabler kind of thing. And I just want to touch on sort of why not center of excellence, because this is a recurring theme in many organizations. And as I said, sort of, it's a bottleneck. It's typically sort of, oh, let's centralize all of the expertise in this one area here. It sort of creates sort of a team and a B team. You have these exclusive groups of experts, and then you have everyone else. And as sort of the days and weeks and months and years progress, this group typically gets sort of distance more and more from the actual work. They used to sort of be very in the trenches doing the stuff most likely, but then sort of things progresses and they are in their own little bubble. And it sort of creates an enormous burden on the rest of the organization. They typically have to pull information out. Typically these are wiki pages, Word documents, PowerPoints, sort of describing this is how you should do it. And it creates an enormous sort of effort to understand the material that they produce. And there's sort of a non-obvious sort of feedback loop. How do we feed back into sort of this cycle here to make sure that that these are actually doing or working, moving in the way that the rest of the organization needs them to do. And there are some other antitypes. I'm going to pull. Of course, we have the DevOps silos. We have the DevOps team silo, where you create the separate DevOps team. We have the sort of fallacy that, oh, we don't need any operations. Of course we do. It's not that we are just firing the people who have all of the knowledge on how to operate these systems. Sort of the DevOps as tools teams, yes. But it's still sort of suboptimal because it's still not including the operations, still having the over-the-wall mentality. Rebranded sysadmin team, I see that a lot. Sort of, oh, well, we need to stay in the with the trends. We have just renamed the sysadmin team to now you're DevOps, and you're still doing the same thing you did yesterday. And then sort of ops embedded in the dev team, which sort of shows sort of a lack of appreciation of the importance and skill required for effective IT operations. And you can, if it's interesting to understand more, you can go to DevOpstopologies.com and read more about these antitypes and sort of their counterpart, what are good types. And that's what sort of the rest of the talk here will be focusing on, because sort of there is a better approach to sort of these team organization, how do we organize this way for having it being the best that it can. And team topologies is really, really simple, unless unlike sort of SAFe and ITIL and these other frameworks that is hundreds and hundreds of pages that and very, very low detailed. This sort of describes in very short and sort of well thought out sort of how is the structure of the organization and how are they going to communicate and work together, and not that much sort of what is sort of the process within this team, and that sort of more to the team to decide. But the majority of the organization will be sort of composed by these stream-aligned teams, and that's your and then sort of other words would be sort of application team, end-to-end team, cross-functional team. Those are sort of responsible for the products and services that the organization is going to deliver. But it's very important that these are aligned with the values of the organization, with the streams, with the business domain that the organization is working on. It's unlike sort of a more cross or other teams that are typically centered around sort of a system. These are centered around sort of business capabilities. What are we actually delivering to our end users? Then you have an enabling team, and many organizations have sort of very similar to this, but it's very sort of strictly defined that the enabling teams, they are only there for a short duration of time, and then they're out. They are sort of there to give the team the competency and the tools and what they need to be able to do a certain sort of function, being sort of governance, security, operational excellence, or learning some new tool or language or framework or whatever have you, and sort of then they're out. They're not supposed to be a sort of permanent crutch to the team. The red box is a complicated subsystem team. I'm not going to cover that in much detail. And then you have the platform team here. So that's the teams. And then it's very, very explicit. How are these teams going to communicate? Because that's the other part here. Sort of, well, unless you also say that this is the way that we are going to work together, it doesn't really make help anything. And sort of there are only sort of 3 sort of team interaction models. Again, this is about how the teams themselves, team to team, are going to interact, and not sort of within a team. And then you have the first one. It's collaborations. 2 teams working together to discover new things. That might be APIs, practices, technologies, etc., and sort of and has a clear goal we are going here in mind. Then you have sort of acts as a service, which means that one team provides another team something as a service, but it's self-service. It's consumed without having to, with very, very little interactions with the team that is providing this. And this is what the platform team is all about, providing platform as a service to the other team. But this isn't sort of exclusive to the platform team. There might be other platform teams, and it might be services that the streamlined teams are providing as well as service to other teams. And then you have facilitation, which is what the primary role of the enabling team. They are in there mentoring another team to be able to achieve something, and then they are out. Again, recapping the streamlined teams, the majority of the team often sort of product teams. They are, of course, they're working autonomous and end-to-end responsibility, but they are aligned with the business needs and the business goals. So they are not focused around systems. They are focused around the business. What are the business delivering to the end users? And sort of this is from the book itself, Matthew and Manuel, authors. The restriction to these 4 team types acts as a powerful template for effective organizational design. And you actually see that when you have a certain constraints, you can allow sort of creativity within these constraints here, and without sort of having to detail all of the nitty-gritty details within the team itself. That isn't necessary. So what is this platform that we are talking about then? And this is sort of the realization that sort of there's a very high cost of switching between developing an application and developing the underlying infrastructure, and the realization that we can make the application team or the streamline teams even more efficient by providing them with the tools that they need to actually do their job. And that would improve governance and security, and sort of provide them with secure by default, and sort of these are adhering to the policies and requirements that we need to adhere with, and you don't need to think about too much on that without sort of only imposing the regulations that you need to adhere to. Actually provide them with services that actually are following what it needs to do, and sort of the context switching as I talked to, and then this continuous infrastructure improvement. Most application-centered teams, they tend to sort of course, focus on developing and improving an application, and sort of the infrastructure part is just sort of a means to an end. It's sort of just there to support the application, and there aren't really sort of this joy or sort of this drive to continues to improve that. So having sort of someone else that are sort of making sure that we are able to improve and continue to develop the underlying infrastructure is very important. Yeah, and it's a foundation of self-service APIs, tools, services, knowledge, and support, which are arranged as a compelling internal product. Autonomous delivery teams can make use of the platform to deliver product features at a higher pace with reduced coordination. So this sort of sets the stage for this platform as a product. It's of course it's very similar to what you expect from or the premise of cloud platforms, except that all cloud platforms are catering to the whole world. They're having so many services and functionality and the different configuration of those that they are not too consumable by the teams that will be building on that. They often sort of tend to need to do a lot of configuration, and there are a lot of parts there that isn't really applicable to what the teams are working on. So this is a more opinionated platform catering towards what are the teams at the particular organization, and what are they actually delivering, what types of services and applications. But it holds true that developing a platform as a product, it needs to be self-service and API first. Without that, it's not as a service, basically. And then this very important note that sort of you cannot really build these type of platforms in one go. What you do is that, and sort of based on assumption, what you think the teams will need, what you do is that you start with one or two teams, discovering what are their needs, but building that globally, delivering when you sort of create something for one team, making that available to all of the teams on a continuous basis, and then continuing to sort of develop from there. And I'm focusing on this developer experience. How are existing and new developers, what's the flow? How are they actually working and interacting with the platform, and focusing on getting feedback from the developers primarily to sort of what can be improved here to make their day-to-day experience better. And then, of course, this evangelization, this sort of, if you build it, sort of is a fallacy when it comes to building product. You actually have to go out there and evangelize for why is this. And that sort of flips it around as well. Sort of we typically tend to sort of not tend to sort of say that this platform shouldn't be required. It should be something that the other teams want to work on. Sort of expect in opposed to sort of saying that, oh, the only thing that you can do is using this platform. It's like, yeah, you can use this, or you can do use something else, and then having the platform teams evangelize for why should they actually use this, and that sort of flips it around instead of being the sort of almighty that, oh, you are stuck with us. And rather sort of this is we are providing you a service, and we want to sort of be able to that it be as compelling as possible. And then, of course, continuing to invest in the platform. You're not sort of what we've seen in the past is sort of pulling out the brightest minds from some of the teams, creating a platform, and then they are sort of going back to what they previously did, and sort of no one is able to sort of actually continue to develop, continue to improve on the platform. And that sort of also is a major problem here. So finding a sort of a stable team, doing the same as you would do with any other application, treating it as a product and having a fixed, stable team that has the ownership and continue to improve in the platforms. One of the most recent DevOps reports saw that this is an increasing trend, that actually 63% of the companies surveyed actually had some form of internal platforms, not necessarily covering all of the platform needs, but in some to some extent. So we see that this is growing, and more of them had several different platforms that they could typically choose by. And then there is this product mindset, and this is equal to any other product, and not something specifically to developing and making a development platform, application platform. But sort of it starts with sort of gathering requirements, reaching out to your users, in this regard being the streamlined teams that will be developing on top of the platform, and asking them and actually communicating with them, what are their pain points, what would they like from a platform, and gathering that requirements, seeing what are the common functionality asked for, and focusing on what are the challenges these teams are facing. Not as much sort of, they would typically tend to sort of go straight to a solution, and it's a little similar to the Henry Ford quote that I don't believe is actually real, but it's a nice quote nevertheless. It's sort of, if it asked people what they wanted, they would have said they wanted a faster horse. There was no such thing as a car. But focusing on what's their challenges, what is the things that needs to be solved or solved in a better way. Then, of course, having a clear product manager for the product that owns the product, and then a clear roadmap, communicate that out, ask for feedback to the plan, and then, of course, sticking to the plan as much as possible. But of course, that doesn't mean sort of a waterfall approach, but this is what we are going to focus on now, unless sort of the circumstances around changes, and then reprioritizing the plan. Then, of course, if you have the new and bright and shiny sort of Formula One racing car, it's no use if people can't drive it. So again, focusing on the onboarding part, that sort of, it's not done until the teams are actually able to use a certain functionality, and then helping the teams actually get started. That's sort of having the documentation and being sort of interactive and being creative in that way. Sort of maybe not do as much Word document, maybe find some more easier way for the developer teams to actually figure out what is the platform all about, and how they're going to use certain functions here. And we see that many organizations are sort of having sort of a name for their platform, and having an internal website where they can find all of the information, and keeping that up to date and very development focused to the various types of applications that the development teams are then working on. And then constantly asking for feedback, regularly ask for feedback. We often use sort of Net Promoter Score to gauge and measure how satisfied are the teams working on top of these platforms on the platform itself. That is typically not something that is done, and typically, unless sort of enough people are complaining, then you typically, only then will there be any actual change. But trying to anticipate that as early as possible, react when, because these requirements will constantly change. Once you sort of reached a milestone, there's always you're continuously pushing the bar, pushing the level there. And as sort of these teams get used to the functionality that was once sort of groundbreaking, they will have new expectation. They will expect that we are continuing to push on and sort of solve new challenges or solve them in a better way. And sort of having this constant feedback loop is sort of making sure that, we are actually delivering on the what's most important to the users, and we are delivering the quality that they are expecting from us. And then typical tools, there is no sort of right and wrong answer here when it comes to sort of what should this platform look like. We have talked about sort of being self-service and API driven, but for most organizations, it starts with sort of build and deploy, having that as a self-service as possible, that you are able to set up a new application, you are able to set up the continuous integration, continuous deployment, all by yourself, all without having to involve other teams in that setup, without having to create tickets and issues, etc. Then the actual runtime, maybe sort of dynamic test environments for testing new experimental features, and be able to sort of create that on your own with as little involvement of other teams as possible, having that just as a service. This traffic management, sort of how do we make sure that once we have some new and bright and shiny and our perfect application, how do we make sure that we get traffic to it, that the correct users can see it and they are seeing it as they should? And then sort of ties into sort of monitoring and sort of being able to actually observe, be able to be responsible owner of the application, having all the insight into the application when it's running, and again having the same tools there for not only for the platform but for across all of the teams. And we typically see that there are some sort of interfaces that are preferred by more and more teams, at least sort of in the high performer end of the scale. We see that the command line interfaces, GitOps are very preferable. Having access to the underlying raw APIs is also make it able to build your own sort of integrations and compose these into higher level workflows. ChatOps is sort of, again, keeping a constant sort of pace there in sort of in terms of popularity. Having to be able to not context switch and go into a different mode, different interface, and sort of, if you're already sort of working in some type of chat system, being able to actually run commands from there. Because these are technical teams, these are highly skilled people and individuals that will be using this self-service capabilities, and we see that they want to, but we cannot cater to every different possibility use case. So having these sort of programmable interfaces here allows the teams to then build their higher level workflow as they see it. And once we sort of see sort of sufficient patterns, once we recognize patterns that, they are composing it this and that and doing like that, we can take that what the teams have been sort of creating on their own and support that as sort of ready-made workflows from the platform side, so they don't need to be continue to be responsible and be owner of that. I see I'm nearing my time here, and what we have found is that Kubernetes is sort of fitting this bar for many organizations. It's not sort of the only thing that can be used, but it sort of plays very well into these definitions that we have laid forward here, being API first, highly modular. Not only is Kubernetes composed by module components in itself, it's sort of very good orchestrator to build your microservices applications in as well. It's declarative, meaning that sort of we describe, or the team or whoever sort of are the users of Kubernetes are describing how the applications want to look like, and then Kubernetes is taking sort of the nitty-gritty details to make sure that it's set up that way, and it continues to be that way with the self-healing capabilities. That if you have said that you wanted 10 instances of the application running, it will make sure that there are 10 instances running if they're not, it will then start its process to get that up and running. And what we have seen sort of more and more sort of third-party services and sort of also these type of platform teams who are sort of building on top of Kubernetes have sort of adapted this Kubernetes operator pattern where you can extend the vocabulary of Kubernetes, extend the Kubernetes API, and provide these higher level workflows. So you can, for instance, create databases and where you sort of have a database object, and then you have what's called a controller that is creating the more lower level Kubernetes components or Kubernetes resources or building blocks underneath. And it sort of takes the full life cycle, not only to provision, but also to operate and upgrade and maintain it throughout the life cycle of this service that it's responsible for operating. And then lastly, for the sort of the metric part, and we see that Kubernetes is having a very rich community and sort of story around monitoring and observability. We have these three pillars. It's important to recognize that we have more than just logging. Of course, we have logging. It's great for debugging. It's great for the audit, seeing who did what, when, and where. But we have other more sort of better ways of gaining insights and alerting on applications. We have metrics, that is structured data delivered from the applications, sort of saying typically it's counters and gauges, something going up and down. Sort of these are the number of requests with a corresponding status code or memory consumption or latency and different parts of that, delivering that sort of as sort of ready-made to the metric system. And then we have distributed traces, which is these different when multiple microservices and these highly composed applications are communicating, sort of seeing the timing and the sequence of when the different parts of the application called what is a really powerful tool, especially sort of debugging these types of errors that might occur in this highly distributed environments, or especially also timing, seeing what timed out or what is actually driving the latency of the overall requests. So that was actually what I had for today. If there are any questions or comments, please post them in the chat, or I'll be happy to answer those. And please reach out if you have any further questions as well.